Okay, so let's introduce the sliding filament model of contraction. And basically, when we talk about contraction of skeletal muscle, we're talking about the activation of cross bridges. And those cross bridges are the sites that are actually going to be generating force. And a cross bridge, if you mentioned from the previous lectures, a cross bridge is formed between those myosin heads and the actin subunits on the thin filaments themselves. And contraction is going to end when those cross bridges become inactive again. So we activate them to contract, we inactivate them to complete or relax our muscle and end contraction. So the relaxed state, if we're talking about any of our skeletal muscle that's not being contracted and is relaxed, we have our thin and our thick filaments overlapping only slightly, and that's going to be at the ends of the A bands. So let me show you a picture. Again, we're assuming our muscle is fully relaxed and there's not any contraction. And we can see this is our A band right here. We know it's our A band because this is going to be our dark band. And our dark band is where both the thin and the thick filaments are present. So if we look through here, from here to here, is where we see both of them present. Right here would be our H zone, and running through it would be these three lines, or the M line made up of myomesin protein right there. So this is what an uncontracted, relaxed muscle would look like, where we have slight overlap at the end of the A band of both the thin and the thick filament. When we want to contract, we're not actually changing the lengths of the filament themselves. Instead, what we're doing is we're sliding the filaments on top of each other, across each other. We're basically taking those myosin heads, the globular heads, attaching them to the G-actin subunits on the thin filament, breaking the cross bridge, reforming the cross bridge, and basically ratcheting along until they overlap even more, not actually shortening them themselves. But when we when we overlap them more, we are essentially shortening the muscle and contracting the muscle. So they don't actually change length, they're just going to slide and overlap more on top of each other. So again, this is under our voluntary control. So when do we contract our muscle is basically when our nervous system is going to stimulate the muscle fiber. What's going to happen is the myosin head is going to bind to the G-actin subunits and form those cross bridges. And that's when we get our sliding or our contraction process beginning. So like I just mentioned previously, so our cross bridges that are formed between the myosin head and the G-actin subunits, they're going to continuously form and break and form and break and basically ratchet along until we've overlapped those two filaments more. So there's ratcheting effect, we're talking or looking specifically at one sarcomere, which is just one unit down the length of a myofibril. But in reality, all of this ratcheting is happening simultaneously in all the sarcomeres throughout the entire myofibril or even the muscle cell itself, causing it to shorten. So when we do contract or overlap these thin and thick filaments even more, a couple things happen noticeably. So if we looked at the two filaments, we would see that our Z discs are pulled closer to the M line. Our I bands are going to shorten. Our Z discs become closer to each other if we're talking about adjacent sarcomeres. Our H zone, which was that lighter region within our A band or our dark band, is going to completely disappear. We no longer have that. And our A bands are going to move closer to each other as well. So here what we can see now is before we had our H zone, which was present between here and here, that's completely gone because now we've overlapped our thin and our thick filaments even more. So we've completely lost our H zone. Our Z bands, because we've lost our H zone, because we've overlapped them even more, our Z lines and our I bands have effectively come closer to each other or shortened in length. So that's what they're telling you right here. And because of that, adjacent A bands are also closer to each other because we reduced our I bands right there. So a couple things to keep in mind about what it looks like when we contract our muscles.